Welcome to This Explainer. Today, we are unpacking a massive foundational topic, the real value of cash. You know, we all interact with money every single day. You probably pull out your phone, check your banking app, see a balance, and naturally feel a certain sense of security. But here's the thing, the invisible forces that grow, or shrink, our wealth often operate entirely in the background, completely out of sight. So, my goal today is to bring those forces front and center. We're going to pull back the curtain on how finance actually works so you can truly understand what your cash is actually worth over time.
So, let me ask you a question. Is £100 today worth £100 next year? It kind of seems like a trick question, right? The physical paper note is going to look exactly the same in 12 months. But financially speaking, treating those two notes as equals is a massive trap. If you just stash that cash under your mattress, you're completely ignoring the massive economic machinery moving around you. We're going to challenge this basic assumption that cash sitting still somehow retains its value. And we'll do it by looking at the mathematical rules of finance, teasing apart the hidden impact of inflation, and looking at the heavy cost of lost opportunities.
Here's our roadmap for today. 1. The time value illusion. 2. Simple versus compound growth. 3. The continuous compounding engine. 4. Inflation, the reality check. And 5. Everyday applications.
Okay, let's jump right into Section 1, the time value illusion.
The absolute foundational rule here is the time value of money. This principle dictates that a sum of money available today is usually worth more than the exact same nominal amount received in the future. Now, why is that? It's simply because money held right now can be actively put to work. You can invest it to earn interest or generate a return. This concept is absolutely brilliant because it forces us to weigh the utility of spending our money today versus the opportunity cost of deferring that consumption. Think about it like this. You could spend £1,000 on a massive new TV today. Boom, instant gratification. Or you could invest that £1,000. The time value of money is the exact framework that tells you how much that delayed gratification could be worth in 10 or even 20 years.
Moving right along to Section 2, simple versus compound growth. Basically, there are two distinct paths your money can take. On one side, we have simple interest. This grows as a straight, predictable, linear function over time because you only ever earn interest on your original deposit. It's steady, for sure, but it's pretty slow. But on the other side, we have compound interest, and this is where the actual mathematical magic happens. Compound interest produces a much higher future value over a given period because it creates exponential growth. You earn interest on your principal, and then, and this is crucial, you earn interest on your previously accrued interest. Imagine a tiny snowball rolling down a snow-covered hill. As it rolls, it picks up more snow, which increases its surface area, which allows it to pick up even more snow on the very next rotation. That right there is compound growth.
Let's completely demystify the formula behind that simple, linear growth by breaking down the core components. If we want to find the future value, which we call FV, using simple interest, we start with our present value, the PV. We then multiply that by 1 plus the interest rate R times the number of time periods, which is T. So for example, if you deposit a present value of £100 at a simple interest rate of 5% for 3 years, your simple interest earned is just £15. That makes your future value exactly £115. Pretty simple, right? But while this formula is a super reliable baseline, it's really just the starting point before we unlock true exponential wealth generation.
Because when we switch to compounding, the formula becomes exponential. Now we're raising our rate to the power of n, which represents the number of compounding periods. Solving for n tells us exactly how long it takes to hit a specific goal. So at a 5% compound interest rate, your money doubles when the growth factor equals 2. You know, you might have actually heard of the rule of 72 in personal finance. Well, that famous rule of thumb is derived directly from this exact mathematical relationship. And it's an amazing trick you can do in your head right now. You just divide the number 72 by your interest rate. So if you have a 6% interest rate, 72 divided by 6 is 12. That means it will take exactly 12 years for your money to double. It's just a remarkably accurate shortcut for understanding exponential growth.
Let's dive into Section 3, the continuous compounding engine.
Let's say you have an account paying a nominal rate of 6% per year. But instead of paying you once at the end of December, the bank compounds it twice a year. That means you get 3% after the first 6 months. Now, because you earn interest on your first 3% payout during the second half of the year, your money actually grows by roughly 6.1% over the full 12 months. This 6.1% is called your effective annual rate, and honestly, it is the rate that actually matters to your bank balance when the year is over. As the number of compounding periods increases, from twice a year to monthly to daily, so does your final future value.
So think about this. What if a bank compounded your interest every single day? Or every hour? What about every single second? Well, in finance, we call this continuous compounding. If interest is compounding continuously rather than in distinct periods, we introduce the mathematical constant e to find the future value. The formula simply becomes your present value multiplied by e raised to the power of the rate times time. It is literally the absolute theoretical limit of how fast compound interest can grow your money. Now, look, in the real world, the actual monetary difference between a bank compounding your money daily versus continuously is often just fractions of a penny. You aren't going to become a billionaire on that difference alone, but mathematically speaking, it's a profound concept that shows the ultimate extreme of time acting on money.
Which brings us to Section 4, Inflation, the reality check.
Okay, let's say you put £100 into a 5% bank account. Your nominal future value after 1 year is mathematically £105. And hey, it looks fantastic on paper. You made £5 just by letting your money sit there, doing absolutely nothing. You check your statement, you see a bigger number, and you naturally feel a little bit richer. The math worked, the bank paid up, and everything seems perfectly fine.
But here comes the gut-punch reality of inflation. Think of inflation as a silent thief in the night. While your bank account statement proudly says £105, what happens if prices in the wider economy rose by about 2% over that exact same year? Well, it means your purchasing power hasn't actually grown by 5%. The real value of that future amount is actually closer to £103 in current prices. Your future value didn't buy you as much of the future as you thought it would. The physical amount of cash increased, but the actual value of that cash, what it can practically secure for you in the real world, shrank right under your nose.
And this brings us to a vital distinction used by financial analysts everywhere: nominal versus real interest rates. Nominal rates are what the bank advertises in big bold letters in the window. They do not adjust for inflation. Real rates, on the other hand, are what you actually experience in the supermarket when you're trying to buy groceries. They adjust for inflation and purchasing power. To figure this out, analysts often use inflation adjustments like those implied by the Fisher equation. The Fisher equation might sound complicated, but it simply tells us that your real interest rate is roughly your nominal rate minus the inflation rate. So, if your nominal rate is 5% and inflation is 2%, your real rate is just 3%. Always remember, the real rate is what determines what you can actually afford to buy.
Finally, let's wrap things up with Section 5, Everyday Applications. One of the most powerful applications of all this math is calculating the future value of an annuity. Now, an annuity is simply a series of level payments or deposits made over time, known in financial formulas as the PMT. Think about putting a steady £200 a month into a pension fund or a savings account. You are creating an annuity. By applying compound interest formulas to these regular deposits, households can perfectly estimate exactly how much money will be available at a target date in the future. Because every single one of those £200 deposits begins earning its own compound interest from the very moment it hits the account, the snowball effect becomes incredibly powerful over a 20 or 30-year timeline.
And it scales up significantly from there. These exact same time value principles are used everywhere. Families use them to compare different time horizons when saving for a house deposit or a child's education. In banking and consumer credit, lenders use them to mathematically map out loan repayment schedules and calculate future balloon payments. And over in corporate finance, analysts use these exact formulas in reverse. They perform what's called discounted cash flow analysis. They look at the massive projected future cash flows from a new factory or a product launch, and they discount those future amounts back to today's present value. This is exactly how they decide if a multi-million-pound capital project is actually worth funding right now.
So, the absolute crucial point is this: every pound, dollar, or euro sitting idle in your wallet right now has an opportunity cost. You are actively giving up the simple, compound, or even continuous interest it could be earning if it were put to work. And even worse, thanks to inflation, that idle cash isn't just missing out on growth, it's actively losing its purchasing power by the minute. Cash is never static. Time is either your greatest wealth-building ally or your purchasing power's absolute worst enemy. So I'll leave you with this. What is the opportunity cost of your idle cash right now? Thanks for joining me for this explainer, and I really hope this gives you a whole new perspective on the real value of your money.